Hello and welcome back. This is part 3 of 3 in our series to configure OpenBSD as a firewall. Now, in this part, we're going to verify our connectivity through the firewall. So the first thing we'll do is I have a client over here, and he is connected to the same network as our firewall's LAN interface. First thing I want to check is that the client has an IP address. We're going to run ifconfig and then on the interface he has. And this client has gotten 192.168.1.100, and he got that because of the pool we created in our DHCP server. Now, another thing we want to check is that he also got the correct default gateway. That was that default the option routers portion. If we do netstat -r to look at the routing table and to not resolve names, and then if we want to look at a specific address family in this case, we're going to use -f and a nit for IPv4. Now the destination of default at the top there and the gateway of 192.168.1.1 is our default gateway, and that goes out EM0. So any traffic that's not in how we talked about the street and the network and host portion, any network that's not in, we'll look at his IP address real quick, that is not in 192.168.10/24 is routed toward the gateway, sent to the gateway. Now though, we do have our IP and our default gateway, so at this point we'll go over to the gateway and we're going to introduce a little bit of the Swiss Army knife of debugging tools. We're going to run something called tcpdump. Now TCP just like the layer 4 transport protocol. But anyway, tcpdump -n to not resolve domain names, I to select our interface, and we're going to start on our LAN interface. So EM0, and we're going to look for ICMP traffic, the Internet Control Message Protocol. I'm going to go ahead and run this. And now we're going to send an ICMP echo request to our gateway. I'm going to go ahead and ping. And we got one packet received here, sourced from 192.168.1.100, going to the firewall's destination IP address. And then it's sourced back from 192.168.1.1, going back to our client as well. So that is our traffic, proves our traffic is getting to the firewall. We also need to know as well, oh, and a fun thing with tcpdump, if you want to know the layer 2 MAC addresses and the frames on the segment, use an E with that. So NEI. It doesn't really matter what order they're in as long as the I is last, as far as I've seen. So now if we do this again, we can still filter the protocol we want. But if I send a ping now over there, now we see the layer 2 information as well, because this is what stays within our Ethernet network in our subnet, broadcast domain. Those MACs are what our requests and replies are getting for us. So that's at layer 2, so the switches are handling this. The host sees it's for it at layer 2, and then looks logically at layer 3 to see that it is for its IP address. But that's just another way to get debugging information as well, to verify that everything is working. And just, it's a great way to learn about networking as well. Very great way. So let's look again at that LAN interface, but now we're going to ping Google. So let's ping Google. And now the packet is still sourced from 192.168.1.100, and the destination now though is 216.58.192.206, and then it's coming back from 216.58.192.206 and going back to our client. Now when it gets there, the router is doing the lookups we had discussed before in our introduction. So first of all, it's natting the packet. So what that means is the pass out on EM1 from 192.168.10/24 to any, and then the NAT2 tells it to change the source, and that EM1 is the source address that we're switching out for the 192.168.1.100. So that is being changed out with that network address translation. Again, we're mapping that private IP to the public IP. So what we'll do after that, again, our next step after we changed it was to look at our routing table. So what the router's doing is taking the address 192.168.1.100, and it's turning that into a network ID. So it's really turning this into binary, but it's turning it into that 192.168.10/24. It takes that, and then it looks at its routing table for the closest match. I'm sorry, not 10/24. I'm telling you the wrong address accidentally. It's actually going to be the 216. So it's actually going to be, it's taking the 216 network here, 58, 192, 206. It's taking that network and it's comparing it against this routing table. And then it's able to find the best match. Now if we look through here, we don't have anything close to this IP address. That's a more specific route, see. So that's why the default route is the best match. It's the longest prefix match. So we just then send it to our gateway of 192.168.0.2 out of EM1. But that's how that's working, and that's how the NAT and the routing is working together in practice. Hopefully that brings it together a little bit better. It makes a lot more sense. But although we looked at the LAN side now, when we know the routing is working, let's look at the WAN side for that same traffic. And we'll see that network address translation in action. So we ping Google. Now our source on the WAN side is 192.168.0.25 going to that same IP address. And when it comes back, it is sourced from 216.58.192.206. So Google's IP address. But the destination is the public IP address of our WAN side, EM1. This is what I mean by that translation, that when it comes back to our firewall, it reverses. It's not changing the source when it comes back. It's changing the destination. So it's changing the 192.168.0.25. It's going to change that on our back to the IP on our clients. So it's changing the destination of 192.168.0.25 to 192.168.1.100. All right, and that's part of that state, and that's what it's changing back. So, lastly, we are going to look at some TCP-based traffic going through the firewall, so we can see port address translation in action. So let's go ahead and just filter by TCP. Make sure you put them in the right order, though. All right, we're going to run an iPerf test, just a quick speed test. We're going to use R to download and C to specify the client. We'll run it for 300 seconds. Alright, lots of traffic, but we'll go ahead and just stop that. That's plenty for what we need to talk about. So, on the LAN side, the traffic is still... most of the traffic is coming back from the server to us. But because it's TCP, we have acknowledgements to tell the server, I'm ready to receive more information. But here is from our source of 192.168.1.100, but now at layer 4 we have port numbers. So our source port is 3439. Our destination layer 3 address is 216.218.227.10. Our destination port number is 5201. So that's the port number that identifies the application on the server, and this is what the source is identifying our client on our machine. So on the LAN side, that's what the IP addresses and port numbers look like. We've established that. But if we look at the traffic on the WAN side, we'll see the port address translation take place. Other things running on the network as well, so we gotta filter that. But we're gonna look again at that traffic. But this is on the WAN side. I'm going to go ahead and stop that. So if we look at this traffic now, it's at layer 3. It is coming back from the server in this case, but it's going back to what destination? The 192.168.0.25. All right, and that source port is still the same on the LAN side, how it was, because now it's coming back from the server to the client. But you'll notice the client source port has changed and been rewritten, so multiple hosts can share one IP address and make, you know, one connection, one socket. So that 52,782 from here, if we look at the other side, even though we have the 52,768, which will actually be a different connection, so it won't be the same, but it still drives the point home. When it comes back through, it is another port number. One more time here. Regardless, when it comes back through, though, it changes the port number back to the original source. So that's how all this is working for us. But that verifies that we have layer 1 through 3 working with our async echo requests and replies, and as well as layer 4 working with our TCP connection. And our NAT, of course, we verified that as well. So with all of that, this is part 3 of 3 in our series to configure a firewall with OpenBSD. I hope this demo, brought it to light a little more and made it make sense. I know it was a little bit long, but I really hope you enjoyed it, and I hope you enjoyed the series. Have a nice day.